Hello everyone. Today we're going to talk about two important data structures used for range queries, prefix sum and segment tree. So let's quickly understand their characteristic first. A prefix sum is simple and works best when the data is fixed. And once we pre-process the array, we can calculate range sums extremely fast. For example, when we want the sum value from the index 2 to 4, then it would be 4 plus minus 2 plus 7. It would be 9. So we're gonna get those values using prefix sum technique. But on the other hand, a segment tree is more flexible. It's designed for situations where the data changes, so it supports both efficient range queries and updates. When it comes to segment tree, I'm going to show you the example later on. Well, our goal is to calculate the sum of a specific range using a prefix sum array. Well, before we start, we're going to place the first value, which is 9, directly into the sum array. So I'm going to throw in 9. And then our loops begin at index 1 until we hit the last index, which is 7. So to compute each cumulative value over here, we're going to add the current value from the original array, which is 2, to the previous value in the sum array, which is 9. So it must be 11. And how about second index? It must be 15. And what about third index? It must be 13. And I'm gonna complete this process. 20 and 15 again. And 23. And lastly, it must be 26. So that's the core mechanism behind prefix sums, just so you know. So now, how do we calculate the sum of a specific range? We simply subtract the cumulative sum just before the start index from the cumulative sum at the end index. So, for example, if we want the sum value from index 2 until 4, it must be 9. But how can we get this value using this array? It must be sum end index, which is 20, subtract sum start index, subtract 1, which is 11. So the result of this operation, it must be 9. So this is how we get the specific sum value from the specific range. So there we go. Well, first things first, I have to make the test case. We need 3 queries, 2 to 4 index, maybe 0 to 7 index, and 1 to 5. Let's gonna check after we write down a whole bunch of codes. Well, let's write down the basic code first. We need the value array, 9, 2, 4, minus 2, 7, minus 5, 8, 3. There we go. And then we need some value with some array with the same size of the value array. And we need to initialize for the prefix sum with the void type. And like I said before, I need to throw in the initial value to the sum array. And then we start from index 1 until last index. And to get the current cumulative value, we need to add the previous one and the current value, like this. And this is how we initialize for the prefix sum. Before we do that, I'm gonna open up the file, the text file for our input data. Our query, like I said before, has 3. So we're gonna do this process 3 times. And I'm gonna get the sum value like this. And we have to input the starting point and ending point. So I'm going to throw in the start index and end index to get the sum value from the specific range. So I'm going to complete this return sum function. Well, like I said before, I need to subtract the value like this. So if I start this code, the first result, if I anticipate it, it will be 9. The second range, which is 0 to 7, it must be 26. And range of 1 to 5, if I calculate it, it's going to be 2, 6, 4, 11, and 6. There we go. This is index 5, so it must be 6. There we go. As we expected, the result of this code is 9, 26, and 6. There we go. Well, now we're gonna implement the same functionality as the previous example, but this time using a segment tree. Well, step 1 is to make answer array using the recursive function, which is our preparation step. And what I mean by that is, step 1 is to pre-compute the cumulative sums for each interval by dividing the array in a binary tree structure. Well, as you may remember from 3DFS video, this binary tree follows a clear indexing pattern over here, the red color. The root node is assigned index 1, and the left child is parent index multiplied by 2. And the right child is parent index multiplied by 2 plus 1. So we use a recursive function that keeps splitting the range until the start index and end index becomes same. So when that happens, we store the value corresponding to that index into the answer array over here. And that value is then returned to the parent node, contributing to the sum of each interval as the recursion unwinds. So I'm going to show you how this recursion works using this ANS array. Well, in the DFS perspective, it always chooses the left child first, and then when they meet the base condition, they return 9 in this case, and filled up with 9 in index 8 over here. And then they just write child and return 2, which is over here, and then filled up with 2 in index 9 of answer array. And when they come to this point, after visiting 2 different kind of child over here, they will be added and make 11 and filled with 11 in index 4 over here. With the same, pattern, I'm gonna do this really quickly without, the further explanation. So they come over here, which is 4. So it must be 4. Then they choose right child, which is -2, and filled at -2. When they come back, it must be 2. And this part must be 2. And when they come back, it must be 13. It must be 13 over here. And then they choose the right child over here, and they go deep down until the base condition, which is 7. And index 12 must be filled with 7. And they choose right child over here. They return -5. And it's going to fill it up with -5 over here. And when they come back, it will make 2. So it must be 2 over here. And they choose over here 6. It will return 8 and filled up with 8 in index 14. And they return 3 and filled up with 3 as well. And when they come back, they will make 11. So I'm going to fill up with 11 in index 7. And when they come back, it will make 13. And they filled up with 13. And lastly, when they come back, it will make 26. It must be 26 over here. And this is how it works. And I'm gonna go to the Visual Studio, and I'm gonna write down the code using this technique. Well, first things first, I'm gonna write down the basic code first. Well, I'm gonna call it segment 3, which contains index and starting index and the last index. And when it comes to index 1, it starts from index 1 when it comes to binary tree perspective. So that's why I throw in 1 for starting parameter. The segment 3 must be integer type. There we go. First things first, we have to consider the base condition when starting index and end index become exactly the same. And we need to write down to the answer array. The value array is the same as the previous example, so it must be 9, 2, 4, -2, 7, -5, 8, and 3. There we go. And then we have to write down to the answer array using the index. Well, it can be end instead of start, but I'm gonna, throw in start in this case. And I'm gonna return answer value. And now we have to split the range using the medium index value. So we have to call the left child first. Well, the index should be multiplied 2, and we can throw in start to medium. This is how we split the range. And the right child should be index multiplied 2 plus 1. And the starting point is changed to medium plus 1. And the ending point would be end. There we go. And then when we come back over here, we have to, mark the answer array with left add right. And then we're going to return this value. So this is all about how we make the answer array. So if I, print out this value, after all, it must be 26. 26, there we go. And then if I erase it, and then I'm going to check the entire answer array. As you probably can tell, it is filled up, you know, from index 1 to 15, which is exactly same as we anticipated. So there we go. Now let's move on to step 2. We're going to implement the return sum function, which we previously built using the prefix sum approach, but this time using a segment tree. Just like before, we rely on recursion. Well, to calculate the range sum, we first need a target interval, target A and target B. Keep this in mind, target A and target B are defined by us. Even if we set the target A and target B to seemingly unreasonable values, the code still works. For example, even if we set the range to -100 to 100, which is target A and target B each, it will correctly return the cumulative sum from 0 to 7, which is our example, start index 0 to end index 7. So it will return 26 in this example, even if we set the target like this. So there's no problem at all, just so you know. And the important thing is that the target A and target B selected by us, remain fixed while the function runs. So in cases 1 and 2 over here, the current start and interval either exactly matches target A and B or is completely contained within it. In these situations, we can immediately return the pre-computed value stored in the answer array. That value either directly answers the query or becomes part of a larger sum as recursion continues. Well, in cases 3 and 4, the start and interval has no overlap at all with target A and target B. Since this segment does not contribute to a valid range sum, we return 0. But if we are computing a maximum instead, we can compute maximum instead of some value. Well, then we would return a very small value and when it comes to minimum query, we will return a very large value so that the segment is effectively ignored. So just so you know, and the remaining cases, when it comes to remaining cases, 5, 6, 7, represent partial overlap. And here we need to keep dividing the interval so it better aligns with target A and target B, just like case 1 and 2. So we repeatedly split the range in half and make recursive calls combining the results until we obtain the final range sum. So there we go. Well, to make this process much easier to understand, let's walk through an example where we set the target range 2 to 5 and see how this algorithm behaves. At the top level, this falls under the case 7, which require us to do the partial overlap. This is case 7. And so we split the current start and interval in half. So I'm gonna split. Starting point is 0 and end point would be 3. Start would be 4 and end would be 7. After splitting, we encountered the situations similar to case 5 and case 6, which still represent partial overlap. So we continue dividing the intervals. Before we do that, I'm going to show you how the case 5 and case 6 looks like, just like this. So It is perfectly matched with case 5 and 6. So we're going to continue dividing the intervals again. So it must be start 0 and end would be 1. Start would be 2 and end would be 3. Start would be 4 and end would be 5. Start would be 6 and would be 7. And as we keep splitting, we eventually reach a point where case 3 and case 4 appears alongside case 1 and case 2. I'm going to show you how it looks like. Case 1 and case 2, and case 3 and case 4, just like this. So when it comes to, 0 to 1 or 6 to 7, it is the case of case 3 and 4. So um, remember our rules. If a segment has no relationship with the target range, we'll return 0. So we have to return 0 in this range. If the segment is fully contained within the target range, like in case of 1, we're gonna simply return the pre-computed value stored in the answer array. So I'm gonna check the answer array. The range of 2 to 3, we have to return the value of index 5 in answer array, which is 2. So this range should return 2. And when it comes to the range of 4 to 5, we have to return the value of index 6 in answer array, which is also 2. I'm going to return 2. And yeah, by combining the valid results, we compute the final range sum value. In our example, the total sum for the 2 to 5 is 4. So there we go. Well, in this case, I'm going to show you how to make the return sum function. So in this example, I'm going to throw in 2 to 4 and maybe I'm going to test with 0 to 7. And 1 to 5. And lastly, I'm going to test with negative 100 to 100. So in this case, it should be integer type. And like I said before, we need the target A and target B. And there is the default setting, default parameter, which is index, start, and end index, which is 7. So if start is bigger than target B, or end value is smaller than target A, which is the case 3 and 4, we're gonna return 0 and call it none, because none would be 0 in this case, because we're computing the sum, the range sum. But when it comes to range maximum value, we have to set none as a very small value like this. And when it comes to minimum range, we have to set a very large value to effectively ignore some segment. But in this case, we're gonna calculate the range sum. So I'm gonna put none as 0. And this is about case 3 and 4. But what about case 1 and 2, which is perfectly matched like this. So if target A is equal or smaller than the start value and target B is greater or equal to end end index, which is our case 1 or 2, we're gonna return the answer value with the index. So this is about case 1 and 2. And we need to do the partial overlap and split it when we encounter case 5, 6, 7, which is these cases. We need to split and recurse. In this case, just like we did in the segment tree function, we need this code. So I'm gonna write down the same code. In this case, it must be return sum. But the parameter is slightly different. Multiply 2, which is our left child. Well, this is about the right child. And then we have to, to return the sum of left and right. So I'm gonna, execute this file, and if I, anticipate the result of this code, it must be 9 and 26 and 6, and it must be the same as this one, which is 26. As you can see, 9, 26, 6, and 26. And even if we set the extremely large and extremely small value for our target, it still, it still works. It doesn't break the code at all. So this is how the return sum works using the segment tree approach. Well, now we are at step 3, updating the values. If we change a value in the original value array, the segment tree allows us to efficiently update the corresponding entries in the answer array as well. For example, let's say we change the value at index 2 to 10. So this is our example. The recursion first moves into the range of 0 to 3, while the 4 to 7 range is ignored because it's unrelated to our target index, which is 2. And of course, 0 to 1 range must be ignored as well. And when we reach the leaf node, representing range 2 to 2, we replace the old value 4 to 10. And this must be updated. And the answer array as well with index 10 will be updated as well. As the recursion unwinds, every parent node affected by this change recalculates its interval sum and updates its value accordingly. What I mean by that is the parent node over here, the value of 2 is not valid anymore, so it will be 8. So this value would be changed to 8 by recalculation. And this value, of course, will be updated to 19 as well. So this value would be 19. And lastly, we have to update this root node, which is 32. So this is how the modify related function works. And let's break down the cases involved. What I mean by that is over here. In case 1, the segment has no relation to the target index, so we stop exploring deeper and simply return the existing value stored in the answer array. And what I mean by that is, like I said before, target index 2 is irrelevant to range 4 to 7. And so it simply returns the value of 13 for the recalculation. And when it comes to case 2 over here, the segment is related to the target, but the interval has not yet narrowed down to a single index, so we continue splitting and recursing over and over. Lastly, in the case 3, repeated splitting eventually leads us to the exact target index, and here we update both the value array and the answer array, then return the updated value. And as that new value is passed upward, all affected parent nodes recompute their sums and refresh their entries in the answer array. To sum up, the modify function over here takes the target index and the new value as parameter, while the node index and start index and end index are handled as default parameters setting during recursion. So there we go. Well, first things first, we need to write down the modify. So I need the target index and target value, and the default setting would be 1, start would be 0, and end would be 7. And if target index is smaller than start, or target index is bigger than end index, which is our case 1 over here. This is about case 1. In this case, we just simply return the value of answer array using index. And what about case 3? Case 3 means we narrow down to the single index like this. So if start and end are exactly the same, we need to update the value using the target index with the target value, and we need to update the answer array as well using index with the target value as well, and we simply return the modified value like this. And in case 2, we still need to narrow down over and over and split it and recurse over and over. So we need to split the range like this, and we need the left child, and we need to call the modify function. The left child would be index multiplied by 2, and start and median value. And what about the right child? It must be median at 1, index multiplied by 2 plus 1, and it should be named as right. And then we have to recalculate for the affected parent node. So it must be left add right. And we just simply return the value of answer array value like this. So well, to make the test case, well, it is a little bit so I'm going to modify the second index with the value of 10, and maybe the sum value must be changed like 2 to 4, right? 2 to 4. It must be 15. What about the entire sum value? It must be 11, 21, 19, 26, 21, and 29, and 32. Yeah, 32 over here. And this must be 32. And what about 1 to 5? 1 to 5, it must be 12, 10, 17, and 12. It must be 12. So this must be 12, and this must be 32. Yeah, as you can see, 15, 32, 12, and 32. And I'm going to show you how the answer array looks like. Well, like I said before, the entire sum value is changed to 32. And we can compare with this with this array, which is 32, 19, 13, 11, 8, 2, 11, 9, 2, 10, negative 2, 7, negative 5, 8, and 3. Exactly same as we anticipated. So there we go. Well, like I said before, we can come up with the maximum or minimum value instead of range sum value. So I'm going to throw in a very small value like this. And I'm going to include the algorithm just in case. And all we have to do is just replace the code to the max function. And over here, there we go. And then I'm gonna rename to return max. Well, I'm gonna anticipate the result of this code first, and in this case, I'm not gonna use the modify function. And 2 to 4, 0, 1, 2 to 4, the maximum value in this range would be 7. The maximum value in the entire range would be 9. And this must be 9 as well. How about 1 to 5? 1 to 5, it is still 7, right? 1, 2, 3, 4, 5. Yeah, 7, 9, 7, 9 as we expected. But how about modifying the fifth index with the value of 10, and I'm gonna modify the last index with 100, and I'm gonna test this test case again. So 2 to 4, well, it won't, this modify situation won't affect this range. It must be still 7. But what about the entire range? It must be 100, of course. How about 1 to 5? Well, like I said before, we changed fifth index with 10. So 1, 2, 1, 2, 3, 4, 5. But we changed this -5 to 10. So in this case, the maximum value would be 10. So just so you know, we changed this value to 100. But in this case, it would be 10. This must be 100. So 7, 9, 7, 9, 7, 100, 10, and 100. There we go. Well, with the same idea, we can come up with the minimum value as well. So I'm going to show you without using the modify function. So in this case, come up with the minimum value. We set a very large number. Well, all we have to do is just change this minimum function. There we go. And then I'm gonna rename it to return minimum. So if I anticipate this code, the result of this code again, 2 to 4, 2 to 4, it must be -2. The entire range, the minimum value would be -5. How about 1 to 5? 1 to 5. It must be -5 as well. This is going to be -5 as well. There we go. Exactly the same. But I'm going to modify the fourth index with -10 and the last index with -20. And I'm gonna print out this value again. Well, still it will be 2 to 4, so I modify 4 to -10. Two to 4, but I modified this value to -10, so it must be -10. And how about the entire range? I changed the 7th index value to -20, so that is the minimum value. It must be -20, -20. How about 1 to 5? Range of 1 to 5. There we go. We replace the value of 7 to -10, but the last index must be modified to -20, but it doesn't affect this range, so still it must the minimum value of this specific range would be negative 10. Negative 10. There we go. Negative 2, negative 5, negative 5, negative 5, negative 10, negative 20, negative 10, negative 20. Well, this is all about today's video, and I hope you find it very useful through this video. Thanks for watching, and see you in my next video. Bye guys.